Hello and welcome to the most simple, step-by-step Trailmakers logic fundamentals explanation video you will ever find. Today I'm going to be covering the most basic aspects of the logic system in the game, as frankly, I don't think they do a very good job at explaining it, as well as literally explaining anything else in the game. This is going to be only the fundamentals. So if you already know logic, we're not going to be going over anything more advanced. This is just going to be for new players that have never ever used the system at all. So, the stuff that you see here primarily won't be covered because it's very advanced. But I wanted to showcase this so you know that I know what I'm talking about. Let's go into the very basics then. Part 1, Understanding the Basics. What is logic? While in build mode, navigate your way over to the Gadgets section and scroll all the way down until you see Logic. Logic in this game is this game's version of programming, allowing you to control many different things with just the press of a button, sometimes even automatically. Don't let the term programming scare you, because it's actually very simple and intuitive once you get the gist. How does it work? Every block that can receive a keybind, including engines, spinning servos, some wings. Every block that can receive a keybind can be controlled by logic, including, but not limited to, other logic. So if you wanted, you could control this one with this one. After you place down a logic block, let's use an OR gate for now. Click the block and click the configure button that pops up, or E for keyboard users. If you have any blocks that can receive a keybind attached to the same build as the logic gate, you should see a gray oval hexagon thing in the corner of that block. So let me just attach one right now. See that? Clicking that block will toggle it, turning it green. What this means is that whatever the output of this OR gate is will be automatically transmitted to every toggled block simultaneously. Speaking of, logic blocks will only ever output a single thing, numbers, and they can only output a single number at a time. Every single block that receives input runs on numbers, even though you don't inherently see them. Whenever you press a keybind, that always corresponds to either a value of 1 or -1, with green being 1 and red being -1. Every single mechanical block in the game, such as engines, thrusters, servos, hinges, etc., can only understand values between -1 and 1, while anything above or below will be clamped. What does clamped mean? Any value above 1 will become 1, and any value below -1 will become -1. Anything between is unaffected, though. You might be wondering, why would I ever want to send a decimal like 0.5? Well, that's because every mechanical block will respond differently to different input values, of course. For example, if you give a servo a signal of 1, its head, the circle part, will go 100% of its given angle towards the green arrow. And what I mean by that is if you give it +1, it will go 45 degrees. It will go 45 degrees this way. And if you give it a value of -1, it will go 45 degrees that way. And when I say it's clamped, by the way, just to give you an example, notice how that doesn't change anything, even though it does right now. But this does change anything, because it starts at -0.5, and then it goes to a maximum of -1. You might also be wondering, what if I give it 2 or more signals? Well, in that case, all input values will be added together and then be clamped. So if you send 0.5 and 0.25, the servo head will move 75% of its given angle. But if you send, again, 1 and 0.5, it will only go 1. For your first 4 steps, The first four logic blocks we'll go over are called AND, OR, XOR, which stands for exclusive OR, and NOR. And while this naming might sound confusing, it is actually very intuitive to understand, and it works like this. AND, if all inputs are not 0, add inputs together, clamp it, and multiply the input by the output. OR, if any inputs are not 0, add inputs together, clamp, and multiply by the output. Exclusive OR, if only one input is not 0, clamp and multiply input by output. NOR, if no inputs, or if all inputs add to 0, then add output. Doesn't multiply anything because this is just the straight output. Now that we have covered the most fundamental aspects of logic, we are going to start covering some more advanced but also more useful ways to use logic. Chaining logic. Now that we've covered the most fundamental aspects of logic, we are going to start covering some more advanced but also more useful ways to use logic. Referring back to our first four logic blocks, you might have noticed that I said inputs, but might not have understood how to assign multiple inputs. Well, whenever you attach the output of one logic gate to the input of another via the green toggle switch, you have added a new input to that logic block. With the AND gate, for example, if you have one or more logic gates attached to its input, then all of them must not be 0, otherwise the AND gate will not output. Like so. Now, in this scenario, even though both inputs are adding together, they add to 0. So it doesn't output anything anyways. But negative and negative, positive and positive, or just if you have a smaller negative and a bigger positive, then they can kind of cancel each other out, so long as the output itself isn't 0. This should also allow you to understand the importance of the NOR logic gate. When you use it like this, you can essentially tell it when you want to let stuff through. If I'm holding E right now so the NOR gate is off, it won't do anything. But so long as I'm not holding E, the value goes through. This is very useful for conditional logic. Now, on to the advanced options. You might have noticed that on the very bottom left, there's a toggle switch called Show Advanced. What this adds is 2 toggles and 3 sliders. When you toggle this, any input that it receives that is negative will be toggled, and any positive will not be toggled. When it's like this, any positive input will be toggled, and negative won't be, and now both inputs will be toggled. This isn't just for keybinds, mind you, it is actually for all logic that goes into it as well. Again. So what happens is if you toggle an input and then you toggle the same sign of the previous input, so if I give it another negative number, even if it's a different number than -1, it'll immediately turn back off again. But if I give it the opposite, like if I have a toggled positive and I give it a negative number, it immediately swaps. It only turns off if I give it a different, or it only turns off if I give it the same sign. The sign meaning that negative or plus sign, but you don't normally see the plus sign. And as you can see, it toggles any input, not just the keybinds attached to it. Secondly, you should notice that there is a moment. Secondly, you should notice that there is 3 new sliders: delay, duration, and pause. Delay determines how long does it take for it to output a value once it receives input. So I'm pressing E, and it took 1 second, even though it immediately got the input. And then it takes 1 second again. Now, if you change the input as it is receiving it, or whatchamacallit, once the delay has started and is finished, even if you modify the input going into it, it does not take an extra second for this one to get in too. Once the delay has passed, if you provide it different data, it will instantly go in. It doesn't have to go through the delay again. The delay is only the very initial input, as you can see. Once it's 0, it will start over again. Duration determines how long it will stay on, even if you're still holding the input. So, just as an example, I'm going to hold Q or E. It activates for exactly half a second before deactivating. This doesn't mean that it's no longer receiving input, it just means that it's no longer outputting. And pause is only usable if you have a set duration. If I set it to 0, you'll notice how it's grayed out. So, I set the duration, and then let's say I set the pause to 0.2. What this means is that it will activate for 0.5 seconds once the delay runs out, and then once this is done, it stops for 0.2 seconds before starting again for 0.5 seconds and then stopping for 0.2 seconds. So, like this. Just as this example, once I give it input, it'll take 1 second to react, then it will activate for half a second, and then turn off for 1/5 of a second, and then turn back on for half a second, and then turn off for 1/5 of a second. See? When there is a duration of 0, this effectively tells the game there is no set duration. Treat it as infinite. And that's it for now. All the basic fundamentals have been covered by me. If I missed anything, let me know. I will be making another video shortly to go over some of the more advanced things that I haven't went over here. If you want to see it, you know, maybe just shoot me a little subscribe or like or comment or just let me know if you want it, you know? That sort of thing. Anyways, bye-bye.